don't forget, real without the rational means it has to be real, which means it cannot be imaginary, but it would be complex. 5.45 repeating. Irrational. Does everybody agree with irrational?
Wouldn't it be rational?
Why would it be rational?
It's repeating.
So remember, if the decimal repeats or terminates, then it's rational. If the decimal repeats or terminates, then you could have written it as a fraction, as a ratio. So this would be rational, which means it would also be real and complex. So please make that note to yourself if you did not remember that. What you could literally write this as would be 5 plus 45 divided by 99. That's how you could write that as a ratio of integers. I think that simplifies to 5 divided by 33, but that's just how I know how to make it really quickly. Okay, so that would be a rational number. 6 minus I. Imaginary and complex. Every number we're studying is complex. So imaginary and complex. Questions, comments, or concerns? No, every number is going to be, if you go back, every number is going to be real or imaginary, and if it's real, it'll be irrational or rational. Right? So the reals split into the irrationals and the rationals, but it can be real or imaginary. And if it's imaginary, it's not rational or irrational. Okay? So good question. Okay, so here's an example of applying the simplifying square roots. We're going to do A and B together, and I'm going to have you do C on your own. What am I going to do first with A? No, I'm simplifying. Say it. Factor it. Factor that radicand. So how am I going to factor it? Square root of?
-4.
-1 times 4. I'm not making a new number. -1 times 4 is -4. And that's already a perfect square, so I'm not going to have to do anything else. So that means square root of? I'll jump in. Step 3. Separate those radicals. Square root of -1 times square root of 4. Square root of -1 is? I. Remember, square root of -1 is I. I squared is -1. Times what? 2. And so I always write that BI, right? So I write it as 2I instead of I times 2. I will accept either, but 2 times I. Okay? B. How would I rewrite the square root of -12? 12 times 12. Now, I want to pause. I'm going to combine steps 1 and 2 over here together because it's going to make my life easier. Are there any perfect squares that are factors of 12?
4 and 3.
4 times, not 24. 4 times 3 would give me 12, right? Remember, I want factors, not multiples. So be careful about that. 4 times 3. And so, I'm going to separate those radicals. Square root of -1 times square root of 4 times square root of 3. I times 2 is 3 a perfect square? So I'm just going to leave it as square root of 3. And it's like 1.7 something as a decimal, and I'm not doing all that. So I'm going to, remember, I always leave my I at the end for A plus BI. So 2 square root of 3 I. Please note that I needs to be outside the square root. Do not ever put your I underneath the square root.
Why not?
Because I is the square root of -1. You're not taking the square root of I. Right? I is the square root of -1. You're not taking the square root of I. Chloe, did you ask a question? Did you ask a question?
I said,
Because of the traditional, you can, but remember traditionally it's a plus bi, where that's the real number. This is the real number.
You're right.
You can do 2i squared root of 3, but this is the traditional way to write it. Okay, within your small groups, I want you to try to complete C within a couple minutes. We'll come back together and discuss it. Please do not forget, you need factors that are what? Not the same. What factors do you need? Not just factors of 50, factors that are, starts with a P, perfect squares. You forgot a really important beginning part to it. This is not what you started with.
Should be 10.
Not necessarily. Talk about your small groups.
So no 10?
Huh?
So no is 10?
Talk about your small groups.
Is it no 6?
25 times what gives you 50? So there's a perfect square.
25 is
We'll talk about it. Do what you think for now. Jay, do you still need that 5 plus outside there? By the way, it's not a 1, it's a negative 1. And also, our 5 and 10
It's for a day.
the whole thing is that we want perfect squares because you can take the square root of a perfect square.
You don't even have this.
Right?
Yes, I do.
So are there any factors of 50 that are perfect squares? 25 times.
You want a cookie? Shoot, I don't care.
You just had cards at the moment.
You can be. Cause so it would be. So it would be.
Thank you. Thank you. Thank you. So this is the most common mistake I saw. And it's okay if you made this mistake. Does anyone see what the mistake is? Thank you.
Oh, that's not what you use.
Why not 5 and 10?
Those are perfect.
Remember, we want a factor. And I want to clarify. Are there always going to be factors that are perfect squares? No. But if there are factors, we only want factors that are perfect squares. So we should have had 25 times 2. Isn't 25 times 2 50? So 5 plus square root of negative 1 times square root of 25 times square root of 2. From what I saw, I think everyone was good up to that point. And so I'm always going to put my I at the end. Square root of 25 was what? 5. Can I take the square root of 2?
No.
So 5 square root of 2, I.
Is that it?
So that's a good question. Do I need to add the 5 and the 5?
No.
Why not? Why yes?
Simplify.
Say this one more time though, Kiani. What did you say? Are those like terms?
Yes.
No, the
Like,
5 part.
let me ask, if I did 5 plus 3x, would I add the 5 and the 3?
No.
No? Why not? Okay, it's not just that 3 is connected to the variable. What's happening between that 3 and the variable? Oh, hey, what has to happen first? Multiplication or addition?
Multiplication.
The multiplication. So I can't add because I can't multiply with that variable. When I have this multiplication here, can I add? No. Multiplication has to happen first because I can't really multiply 5 times square root of 2 times I can't add it to that 5 yet. Okay? Questions, comments, or concerns? So I had an excellent question in first block. It was. Because square root of 25, what is that? 5. Well, it said, do I not need to get both a positive and a negative solution? And Jake Wan's saying no. Why not? You just don't. No, it's never just because you just don't. Listen to the language again of that student. Do I need to get a positive and negative solution? But what's wrong with that language? Pay attention to that.
Positive and negative, that ain't right.
It's more, well, you could get positive and negative. We'll look at that in a second, but it's not a solution. Do I have an equation here?
No.
So I'm not solving. The reason why we got a positive and a negative here is because when we take the square root, right, we really only get a 5, but is that the only thing that could have made that equation true?
No.
No. It's when solving an equation that you have to get the positive and the negative because both of them made the equation true.
So we don't need to get what he was asking.
Correct. Because we're not solving here, what are we doing? We're simplifying. We're rewriting it, right? When simplifying, you don't get a positive and a negative, only when solving because both the positive and the negative would have made that equation true. Questions, comments, or concerns before we look at activity 6.3? Alright. This part is super, super, super easy, but you need to pay attention and actively engage here to make sure you understand. First off, we actually discussed this a little bit last week when we started talking about, hey, there are complex roots out there. Anyone know what this would be called?
Complex plane.
Complex plane, right? It's in the textbook. Pay attention to it. It's called a complex plane. What makes this a complex plane?
The
It has-
imaginary at the top.
It's not just imaginary on the top. Imaginary is my y-axis. Imaginary numbers are on the y-axis.
And real on the
And real numbers are on the x. So why in the world is 2 plus 3i right here?
because the real I in imaginary.
Use the axis to
So over 2 and then up 3.
Over 2, so like this way?
No, right
To the right, 2. You call me a fool. So we want to know this and remember that the x-axis is my real numbers. So to the right 2, not just over, to the right 2, plus 3i means up 3. Okay? 2 plus 3i, that's it. Graphing complex numbers, super easy. Okay, so show of hands, I need someone to volunteer to tell me how to get 5 minus 3i. Jesus. Yeah, how to graph 5 minus 3i.
You go right 5 and then down
So to the right 5, down 3.
3.
Anybody want to push back on that or ask a question?
not like
Not like push back?
Hold up. Don't that
Why don't you go right? Why don't you
Let's-
go left?
Okay, there's a good question. Pushing back on it. Should we go right or go left?
They don't have a negative in front of it.
So is that 5 positive or negative?
Positive.
Positive 5, so it's to the right. Notice the minus 3 is on the complex part, so it went down. So it's a great pushback. Okay, so 5 minus 3i. I want someone else to volunteer to give me negative 3 plus 4i. Caleb. Sheridan, I'll get you next, huh?
Left 3 and up 4.
Left 3, up 4. Negative 3 plus 4i. Does anyone want to push back or ask a question? That's it there, okay?
oh my god.
Sheridan, did you want to do C for us?
Yes, go to the right 8 and up by 6.
So here,
Yes.
okay? Alright, so let's look at one that's a little bit different. E. Can someone volunteer to give us E? Preston, Keyshawn will get you next.
Down on the y-axis.
Go down on the y-axis
By 6.
by 6. You know what I'm saying? I said E, right?
You said E.
Yeah, so I'm good.
Negative 7.
So for negative 7, what am I going to do?
Go on the right, go to
Just
the
go
left.
to the right.
Go to the left, how far?
Yeah.
Do I go up or down? No? Why
Does
not?
it have an imaginary number at the top?
It doesn't have an imaginary heart, which means we could write as negative 7 plus what?
0.
0,
Period.
I.
No, I'm just sticking with negative
Listen, be careful, it's not -7i, it's -7 plus 0i.
stuff. I'm just putting negative
Okay.
stuff.
Can I get a volunteer for F? Liam,
You go up on the y-axis 1.
go up on the y-axis 1,
Yeah.
that's it? Down?
What?
Okay, so, Momar, give me your logic, because I'm going to leave Liam's there for now. What's your logic for why it's going down and not up? Does I equal a -1? Square root of -1. But remember and note, this is positive I, this is negative I. Does this say negative I over here? That's a good thought, but it's positive, so it is Notice you can also write it as 0 plus 1i. The a from that real, is that what you said, the a? Something about the a? Because you could put that 0 there for the x if you want to, but it's also just I. Not quite. Can anyone tell me this I right here?
What's that?
-4, square root of -1.
That doing too much, though. Explain out, though.
So go what? Go left how far?
Negative 4.
So go left 4,
Yes, sir.
and then what?
Down.
Down.
1, and then.
No.
3.
No.
Okay, so let me remind you this. What is square root of -1? I, right? So square root of -4, I, minus 3. But remember, we want a plus bi. So it's to the left how far? It's just to the left 3. And then down 4. Alright. We will pick back up here tomorrow. We need to get through this somewhat quickly so that we can knock out activity 6.4 and get to activity 6.5 because we're going to have an understanding check on Thursday. Okay. So you might want to go ahead and start studying your number sets. Please notice by this point you can do almost every term on the Big Ideas graphic organizer on the back side. That's why it is due on Wednesday. And then also due on Wednesday will be all of lesson 6, the write, the practice, and the review. You can already do everything from this practice except number 6 on the practice. That's it. Everything else you should be able to do.
I need a picture of that.
I would take a picture. Understanding check on Thursday. Yes.
I'm working on something.
Girls do too.
Because it was.
For those of y'all who turned in a graphic organizer, I will give feedback quickly so you can take it before you go. Actually, Kadeja, you're the only one in here. Kadeja, if you can wait just a couple minutes, I'll give feedback on this. Okay?
Now you were staring around. A simple glaze was gonna find.
Hey,
You were staring at it, bro.
I'll come back.